Hello everyone. In this video, you will be seeing introduction to activation functions in neural networks. First, let us understand what is the main purpose of activation function. So the main purpose of activation function is it brings non-linearity in our data. So why this non-linearity is required is in order to enhance the learning process. So in case of neural networks, we'll be making use of different layers, right? Like input layers, hidden layers, and output layers. So we have seen our hidden layers, more the number of hidden layers, it tries to capture the deeper the complex patterns. How are they able to do that? Layers, that is input layers, hidden layers, and output layers. So we have seen in case of hidden layers, it tries to capture more complex pattern. So more the number of hidden layers, more the complex pattern it usually extracts, right? So how are they able to do that? Because of these activation functions. It basically introduces non-linearity, okay, so that the learning process can be enhanced. So there are different activation functions. First is sigmoid, ReLU, leaky ReLU, softmax, and linear activation function. A model without any activation function usually act like a linear model basically. If you don't want any non-linearity to add in our data, so in such a case, we can make use of linear activation functions. Then softmax is basically applied in our output layers. Suppose, consider we are having three different images like cat, dog, and monkey. So these are the three images that we are going to categorize depending upon the inputs that we provide. So we are having three different labels, right? So in our output layers also, we'll be making use of three different neurons separately for cat, dog, and monkey. Now you want to decide, okay, for the given inputs of different features, okay, that may be a pixel informations. Depending upon that, you want to decide whether it's a cat, dog, or monkey. So in such a case, the neurons in our output layers will have some activation function, right? For those activation function, we'll be applying softmax. Okay, it is applied in our output layers, mainly deals with multi-label classification. Multi-label classification is more than two groups. Next is ReLU and leaky ReLU is mainly applied in hidden layers. Whereas sigmoid function is basically applied in our output layers, okay, that deals with binary classification problem, like yes or no, whether the loan is approved or not. So in such a cases, we'll be making use of this sigmoid function. So sigmoid and softmax is basically applied in our output layers, whereas ReLU and leaky ReLU is basically applied in the hidden layers. So now let us understand each and every activation functions. First is sigmoid function. So sigmoid function is basically used for binary classification, and that is used only in the output layers. So it usually converts the value into 0 and 1. Suppose, consider the scenario where a loan is provided to a particular person or not. So it's an yes or no case, right? So S means 1, no means 0. We are constructing an hidden layers, output layers, and input layers. So depending upon the features that we extract, it may be X1, X2, or X3. So if you're going to approve the loan, it may be based on gender, age, salary. So we are going to consider three different features. So depending upon those features, and then the neurons in our hidden layers. Suppose we are going to make use of two neurons. Each and every neurons will receive the features, and then we'll be combining. Since it is in a multi-classification problem, there should be only one neuron in our output layer, and this would be the value of y. Okay, suppose gender is male. Okay, we are going to provide value as 1. Okay, and age is 60. Then salary is 100K. So when we provide in such a case, what happens? Finally, it will be summing them up and we'll be getting a value of y, right? So what happens is that if y value is equal to 0.8, okay, once after receiving this value of y, we want to check with respect to that of your sigmoid function, which is equal to 1 divided by 1 plus e power. Here the x value will be 0.8. That is the output that we have received. So e power negative 0.8. Okay. On applying this function, okay, it results value 1. Or you can make use of the sigmoid function. Okay. In case of sigmoid function, it usually maintains a threshold of 0.5. We have received value output y equal to 0.8, right? So if value is greater than 0.5, then the value will be 1. Okay. If it is less than 0.5, the output will be 0. Okay. Since the value is 0.8, okay, which is greater than 0.5, this implies that for this particular kind of input data, the loan would be approved to that particular person. This is how it decides. This is the purpose of sigmoid function. This is basically applied in our output layers. Next is ReLU activation function. ReLU activation function basically converts all the negative values into positive zeros, and positive values will be taken as such. Function, it basically converts all the negative values into zeros, and the positive values will be taken as such. So the original values will be taken. Okay. So it should be used as an activation function in our hidden layers. So it will be of the form maximum of 0, x. So let us consider x value as 10. So when we apply ReLU activation function, it's nothing but maximum of 0, 10. So the value will be 10. Okay. X is equal to 50. So when we apply the value 0, 50, what happens? The maximum value will be 50. Let's take negative values. X is equal to negative 25. So 0, negative 25, it will be 0. Okay, the maximum between these two values. So for all the negative values, the graph will be 0. And for positive values, it will be taken as such. Okay, if you are taking value as 3, the value will be 3. If the value is 4, the value will be 4. Okay, if the value is 5, the value will be 5. So correspondingly, the values will be taken such that we will be getting a linear value in case of ReLU activation function. So in case of ReLU, it completely ignores our negative data. Suppose if you want to consider a little bit importance to our negative data, then we will be making use of leaky ReLU. So in case of leaky ReLU, it is also used as an activation function in our hidden layers. Okay, so here the function changes in a little bit way, like maximum of 0.1 times x, comma x. So suppose assign value of x as 1. Okay, maximum of 0.1, 1 is, it will be 1. Okay, there is no change in our positive values. So positive values will be an original values. Now consider value of x as negative 1. So maximum of negative 0.1, negative 1 will be. So in our number line, negative 1, here we'll be having value 0. So when we apply maximum function to our negative 0.1 and negative 1, which will be the maximum value? Negative 0.1, right? So without ignoring completely all the negative data, we'll be providing some importance to our negative data with the help of leaky ReLU. Next is softmax function. So softmax function is basically used for multi-label classification problem. So as we have discussed, depending upon the inputs that we provide in our input layers, the output will be decided whether it comes under, whether the given image is cat, dog or monkey. So for each and every labels, we'll be providing different values. Okay, for each 3 neurons will be provided depending upon the labels in our output layers. Okay, so now suppose we have got values, like we are going to consider 3 different features, x1, x2, x3, 2 neurons in our hidden layers. We are going to sum them up. Once after receiving the output from HL 1.1 and HL 1.2, we are going to combine them, right? So we'll be getting the value. Okay, that is our output label. Suppose assign the values as 1.3, 5.1, 2.2. This is a value for cat, this is a value for dog, and this is a value for monkey. Okay, so the softmax function is basically e power ai divided by summation of e power ai, where ai is nothing but the output value of the class labels. Okay, output value of the class labels. So here, consider the output values of cat. Let's apply the softmax function value for it. So ai will be equal to 1.3. So the function will be e power 1.3 divided by summation of e power ai, right? So e power 1.3 plus e power 5.1 plus e power 2.2. This is how the calculation would be. Okay. So you'll be getting 0.02. Then similarly, you want to take the second output data and you have to apply the softmax value. So what happened is that the output value will be converted to probabilities. Okay. So among the probability value that we have received, the maximum value has to be chosen. So this is how it will decide the given image is dog. That's the end of introduction to activation functions. Thank you.